In this lesson, we are talking about finding the missing side of a right triangle. Now, in any right triangle, we have three sides. It's triangle, right? And we specifically have a right angle in this case. And that right angle is going to come in handy for helping us label our triangle, which is kind of crucial to being able to use the Pythagorean theorem. Now, really quickly pause this video and write down the Pythagorean theorem in that spot on your notes. You should have written down a squared plus b squared equals c squared. Now, if you recall from a previous lesson, we talked about what a, b, and c are. A and b are both the legs. They are the sides that form that right angle. In this triangle, we have a or b, or we could say the opposite, okay? It doesn't matter if you label shorter side or longer side A or B, as long as it is not the longest side in a problem, okay? So then we have C, which is our special word called the hypotenuse. And I like to use the right angle as kind of an arrow. If you look at it, it points to the longest side. The right angle always opens up to the longest side, and that longest side, our hypotenuse, is always going to be C. Always. Okay, so let's actually apply this now to finding the missing side of a right triangle. So in this right triangle, I have 20 and 21 are my legs. In this case, I'm looking for a missing hypotenuse, so I'm going to use my Pythagorean theorem. I have a squared plus b squared equals c squared. In this case, I have a and b, or b and a, does not matter which. I personally like to use the a as the shortest side and b as the longer of the legs, but you can choose either and you're still going to get the same answer. So I'm going to replace a and b in my Pythagorean theorem so I can solve for c. I am always going to use parentheses just to make sure that I don't accidentally miss anything, okay? So I have a is 20, b is 21, and I'm going to start squaring those for my order of operations. I'm going to simplify within that left side first before I actually start solving, okay? So we have 20 squared, which is 400. 20 times 20 is 400. And 21 squared, which is 441. And that is equal to c squared. So I'm going to add these together. I get 841 is equal to c squared. Now I did have you memorize up to the perfect squares of 20. And this one is a perfect square, but it's a little higher. I don't expect you to necessarily know it. You can use a calculator sometimes when we're doing Pythagorean theorem, but I will show you the answer in this case, okay? So, in case you didn't get the hint there, I am now going to try to eliminate that exponent of 2. In our previous lessons, we discussed how to solve an exponential equation. So I am going to do the square root, the opposite of that square, okay? And then I get that 2 to go away because c is now alone. And the square root of 841, as I mentioned, is an integer answer. I could get a positive or negative here, but because we're talking about the side length of something, right, the sides here, c here, that means that I am only going to stick with positive because I can't have a negative distance. My answer will be 29 because 29 times itself equals 841. So C, our missing hypotenuse, is 29 units long. Go ahead and pause the video, give these a shot. There are 2 here. One gives you your A, your B, and your C to plug in, and the other one has a picture, so you will have to identify what goes where. Give it a pause, get those done, and get them checked before you move on. Alright, now sometimes we will be working on finding a missing leg, not a missing side, or not a missing hypotenuse. So, again, A and B are legs, and C is the hypotenuse. Hypotenuse is always the longest side. When it's not always obvious, like this particular example, we use that right angle to point us in the right direction, literally. It will point at the right direction there. So A is going to be this square root of 2. B is going to be the missing side, and C 2. Or I could have b be my square root of 2 and a be my missing side. Doesn't really matter. I'm going to stick with what I have just because it's already there. So I have a squared plus b squared equals c squared. Again, I'm using parentheses just to keep it organized and clean. Oops, my bad. Let's go ahead and put parentheses there. Okay, so I have c squared is 2 squared, and I have a squared is the square root of 2 squared, and b is just x, a, b, whatever you feel like putting there. Okay. Now I'm going to square a square root, which, if you recall, is the opposite. So I end up with just 2 here, plus x squared equals 2 to the power of 2, which is 4. Unlike the last time, here I have to do 2 steps to solve this equation, not just the square root, okay? So I do need to eliminate this 2 before I can take the square root of this, because we have our inverse order of operations, where I do exponents close to last, and I'll definitely get rid of addition subtraction first. So I'm going to subtract 2 from both sides. X squared is still x squared. I haven't completely isolated x by itself yet, and I have 2 on the opposite side. So I will do my final step, take the square root of x squared, get x alone, and my answer will be the square root of 2. Now, could I find an approximation for this? Absolutely. Do I need to? Definitely not. Leave it as a square root of 2 unless the problem specifically tells you to approximate to the 10th place. Okay? Finally, go ahead and pause the video on this. Give these a shot. There are 2 problems here, one which tells you your A, B, and your C to plug into your formula, and one that gives you your triangle. Please keep in mind when you are doing this that you can use a calculator, but also these 2 examples do have integer answers. Okay, so please don't leave your answer as a square root. You should have a perfect square to find an integer answer. Get that checked and then finish the rest of the lesson. Have fun.